All right, let's see. I just got cut off a little bit at the end here, so I just wanted to mention this one more time. So we had an Obama's approval rating of 62%, and you're going to go poll 100 people. How many people do you expect to approve of his work? This is a little precursor for Chapter 6, but actually Section 6.2 to be honest. But what you do is you multiply, say, okay, 100 people are going to be asked, but 62% of them are going to approve. 62% of 100 people would be 62.62 times 100, which is 62. All right, next, at least probabilities. All right. So suppose a probability experiment is rolling a 10-sided die. Construct the sample space. Well, hold on, let me pause this for a second. There, I just typed without you. But we already ran into the 10-sided die before. It's 0 through 9. It's a little weird because the 10th side is not 10 as it is with all other dice. It's 0. All right, event E is rolling at least a 6. List the outcomes in event E. All right, so let's start with that. The list of outcomes, at least 6, actually means 6 or more, right? So 6, 7, 8, 9. What's the probability of E? Okay, well, the probability of rolling a 6, 7, 8, 9 is equal to 4 out of 10, right? All right, what's the complement of E? Well, the complement of E, you know what? Just occurred to me. I should label this E. And then while I'm on the subject, there we go. All right, the complement of E, i.e. E complement, would be all the numbers in the sample space that are not in E. So 0, 1, 2, 3, 4, 5. Okay, so what's the probability of the complement? The probability of E complement is equal to the probability of not getting E, which would be 1, 2, 3, 4, 5, 6, right? There's 6 numbers there. So 6 out of 10, or 0.6 if you want the decimal. All right. What about rolling at most a 5? At most a 5 would be event F. That's rolling 0, 1. That's boring. Let's not do at most 5. Let's change this. How about rolling at most 3? Yeah, let's do that. Sorry, I'm going to change that. 0, 1, 2, 3. Okay. All right. So if that's event E, or event F, right? That's its outcomes. What's the probability of F? That would be, the way I've done it, 4 out of 10. Man, I keep picking these ones, 4 out of 10. Maybe I should change this again. How would we do this? At most 2. There we go. Something different. So let's make it at most 2. Hold on. And that would make it 3 out of 10, right? Oh, man, I'm working hard for it. All right, so what's the complement of F? Good question. Well, the way I've got it written out now, at most 2, would be F complement would be all the other numbers. So 3, 4, 5, 6, 7, 8, 9, which would make it 7 out of 10. Now notice 3 out of 10 and 7 out of 10, you know what they add up to? 1. Okay. Now the kicker in this is that at least in mathematics actually means, and it's kind of weird because you look at it and you think least must be less than, right? But not really. At least actually means greater than or equal to, right? Mathematically, that's what it stands for. And at most really means the opposite. It means less than or equal to. There, the words at least is mathematically equivalent to, hold on. Oops. That symbol, greater than or equal to. And at most is mathematically equivalent to that symbol, the less than or equal to symbol. And it's a little strange because it seems like they're backwards, but that's how it rolls, right? So at least means that much or more. I want at least $1,000 a month or something like that. That's more than. Whereas I want at most 2 kids means I want less than or up to 2 kids. All right, it helps with that. I'll see you here for the next page.